Number 2 definition. A function f is continuous from the right at a number a if a limit when x approaches to the right side of a of f of x equal to f of a. And f is continuous from the left at a if the limit of f of x as x approaches to the left side of a equal to f of a. In example number 3, we want to check to see the function f of x is the latest integer continuous in which directions. So let's just look at an integer number. Because integer, you can see that there's some like a step, but all the number like 2.1, 2.5 decimal number is always continuous, right? So for example, just take a look at 2. Then the limit on the right side of 2 of the function f of x is equal to, that means we go this way, is equal to 2. And f of 2 is also equal to 2. So from this, we can see that the function f is continuous from the right at 2. But now let's do the limit when x approaches to the left side of 2 of f of x. So when we go from the left side of 2 of f of x, we got the limit is 1, but f of 2 is 2. So from this, we can say that f is not continuous from the left at 2. So in general, we can check the integer numbers like 1, like 3, like 4, 0, -1, and so on. So instead of checking the 2, you check the other numbers and it will work the same way. Okay, so I will, instead of using the 2, I will make it more general. I'm gonna make when x approaches to any integer n and the function f of x, the limit of that function will give us the answer is n. And f of n is also n. Then we say that the function f is continuous at n. And when we go from the left-hand side of the integer, the function f of x, the limit will approach to n minus 1. And f of n is equal to n. So they're not the same. So we can say that the function f is not continuous from the left side at 2. Definition number 3, a function f is continuous on an interval if it is continuous at every number in the interval. If f is defined only on one side of an endpoint of the interval, we understand continuous at the endpoint to mean continuous from the right or continuous from the left. So example number 4, we want to show that the function f of x equal 1 minus square root of 1 minus x squared is continuous on the interval -1 to 1. So if you draw the interval from -1 to 1, so we have 3 parts right here that we need to identify. We have at -1, at +1, and we have the open interval from -1 to 1. So first of all, I want to check to see if my number A between in the open open interval from -1 to 1. Then we use the limit law. So limit when x approaches to a, for a is between -1 and 1, of the function f of x is equal to the limit when x approaches to a, 1 minus square root of 1 minus x squared. So I'm doing both sides for the limit in this situation. So we can separate, right? So we have the limit x approaches to a of 1 minus the limit of the square root 1 minus x squared, x approaches to a. So it's a constant, so it's equal to 1. And the second one is become the square root, the limit x approaches to a of 1 minus x squared. So we are doing this by the law number 11. So you need to go back to the other section and check, okay? So we have 1 minus. Now, this part is just the polynomial, so we just substitute. So we got the square root of 1 minus a squared. Now, let's check this. F of a. F of a is 1 minus square root of 1 minus a squared. So what can you say? What can you see is that the limit of function f of x when x approaches to a, this one is from the left and from the right. And the function at a give you the same answer, which is 1 minus square root of 1 minus a squared. And the function is defined on the interval from -1 to 1. For a is in that interval, so it's defined at a, okay? So by the definition of continuous, we can say that the function f of x is continuous at a. Now we're gonna check the endpoint. So we go back to the interval before because our function is between -1 and 1. So we want to know if we approach from the right hand side of -1 and we approach from the left hand side of 1. Then we want to know it's continuous. So let's calculate the limit, right? Okay. So let's find out the limit of x approach to -1 on the right hand side of the function f of x. And what all we need to do is just plug in -1 into the function. So we got 1 minus square root of 1 minus -1 squared. Because we have function f of x, we can use this, right? We use this one. We use this. Okay, so we can calculate and then just simply plug in the number, okay, from the idea that we have before. So we got the answer is 1. And that gives us exactly as the function f of f that evaluate at 1. And also, we calculate the limit as x approach to 1 on the left-hand side of the function f of x. And it gives us the answer is also 1. And it's also equal to f of 1. So from this one, we can say that the function f of x is continuous on the right side of -1. And from here, we can conclude that f of x is continuous on the left side of 1. Okay, so go back to the picture that we have before. We have the function continuous on the open interval -1 to 1 is also continuous from the left side of 1 and from the right side of -1. So it's continuous on the whole interval, closed interval from -1 to 1. So we can conclude that f of x is continuous on the closed interval from -1 to 1.